to practice some
All right.
today.
So, last time we were together, we did critical numbers.
Yeah, I'm still not done with that assignment because someone didn't help me. Do you already have this
Now,
test?
I screwed up. I had it correct on the notes. Where critical numbers occur where the first derivative is equal to 0 or where the first derivative is undefined, given that it is a different point where the original function is undefined. I forgot about that, which screwed up everybody because, yeah. So, if it's undefined at a different place than where it was undefined originally, then it's a critical number. But if it's undefined at the same place where it has an asymptote, then it's not a critical number. Sorry about that. That was my fault. I was bad teaching. Today, we're going to do increasing, decreasing. Where is it increasing and decreasing? Well, it's increasing and decreasing between the maximums and minimums. Where do maximums and minimums occur? At the critical numbers. Oh, this goes hand in hand. Okay. Where is this increasing? So we take the first derivative of that, which is 4x to the third minus 6x squared. We set it equal to 0, factor out a 2x, and we get, factor out 2x squared, and we get 2x minus 3 equals 0. So x equals 0, and x equals 3 halves. You said 2x squared equals 0, and 2x minus 3 equals 0. So x equals 0, and x equals 3 halves. So here's 0, here's 1, here's 2, here's 3 halves. Because 3 halves is 1 1/2. Okay, so what we should do is pick out points in between these. Like 1 is in between them, right? If we put a 1 into the first derivative, it tells us the slope. Okay? We can pick any number that's not these numbers. So you go in between and on each side. Just follow, okay? Before you have 7 million questions. Put in a 1. What does a 1 make this out here? A positive 2. What does a 1 make this in here? Negative 1. A positive 2 times a negative 1 is a negative number. So the slope is negative here. Okay? So let's try out here, where negative 1 is. Put a negative 1 in here. Negative 1 squared is a positive 1 times 2 is 2 out here. Put a negative 1 in here, we get a negative 5 here. A positive 2 times a negative 5 is a negative. So what's happening here is it's decreasing, and then it's decreasing again type of thing. Okay? So it's decreasing, it flattens out decreasing. If we put in a 2 here, it's positive, and then it's positive, so it's positive. So the slope is negative, negative, positive. Where is it increasing? Where the slope is positive, which is after 3 halves. Or like Kennedy says, it's A, because it's always A. Okay, so that's how to determine increasing, decreasing. We draw a number line, and we check. We use checkpoints. Now, a little bit of algebra 2 review. If this is to the second power, it's a double root. When it's a double root, it will not change. So if it was negative before, it'll be negative after. It only changes when the power on the root is odd. So since this is a double root, that's why I went negative and still stayed negative. But since this is a single root, it changes from negative to positive. If there were 3 roots and they're each to the first power, then it'd be positive or negative, positive, negative, or positive, negative, positive. Yep. Okay. Where is this function decreasing? Well, where are the critical numbers? Okay. Well, to figure out where this is decreasing, this is kind of a nasty one, isn't it? Okay. This is the first derivative, so it's not so nasty. Okay. So what's happening here is at negative 3 is an asymptote. So at negative 3 is an asymptote, and at a positive 2 is a root, because x minus 2 equals 0, so x equals 2. So those are the 2 places we check around. Okay. So what's in between negative 3 and 2? What's even easier? 0. Okay, so if we stick a 0 in here, I get a negative 2 on the top, I get a 9 on the bottom. Negative 2 ninths is a negative. Now, over here is like negative 4, right? So if I check a negative 4 in here, I get a negative on the top. Negative 4 plus 3 is negative 1. Negative 1 squared is a positive 1. So a negative over positive is a negative. And then at 2 past 2 is a 3, right? So if we put in a 3, we get a positive over positive, which is a positive. Okay, so this is why asymptotes aren't critical numbers, because it doesn't always change as at an asymptote. Okay, so where is it decreasing? Well, it's decreasing from negative infinity to -3, and also from -3 to 2. Why didn't I just say negative infinity to 2? Because it's not defined at -3. Since we're not defined at -3, we can't say it's decreasing at -3, because there is no graph at -3. Okay, so what does the graph look like? Well, we have an asymptote at -3, so the graph is probably going like this, and then at 2 we have a root, so then it's negative, and then at 2 it becomes positive. It would look something like that. I don't know. I would do parentheses because that 2 is where it changes. So it's not included. Well, this is the first derivative, so no, you couldn't. I mean, yeah. Well, anything below the x-axis is a negative slope. Anything above the x-axis would be a positive slope. So yeah, you could. To learn the science behind the math, or the math behind it. So, all right. So the first derivative is this. The first derivative equals those three numbers. Okay. So how many points does the graph have a relative minimum? So you have a critical number at -2, -1, and 3. -2, -1. Let's throw a 0 here. 3. Okay. So how many times do they appear? Are any of them? Do any of them have a multiplicity of more than 1? No, they're each 1. So they should change each time. The easiest number to check is 0, right? So if we check the 0, makes this positive, makes this positive, makes this negative. What's a positive times a negative? So it'll be negative here. The slope will be positive here. It'll be positive here. And it'll be negative here. Okay? So if the slope goes from negative to positive, what is this point called? A minimum. It's a relative minimum. When the slope goes from positive to negative, it's a maximum. When the slope goes from negative to positive, it's a minimum. How many minimums do I have? 2. How many maximums do I have? 1. 1 relative max, 2 relative mins. See how that works? Okay, this isn't the first derivative. This is the actual function. Okay, so since this is the actual function, I have to find the first derivative of this bad boy. And if I were you, if I were Evie Lurs, I'd put it straight into my graphing calculator and figure it out. We've had this discussion already. You just were oblivious to this discussion. No, you could graph it and just look at the graph and figure out where there's a relative minimum. Because this would be a combination of the product rule and the chain rule. Nobody wants to do that. So what would it look like? All right. So we got on with y equals clear. So negative of x plus 1 times x minus 1 quantity squared. If we go zoom, 6, just like graph. Okay, I have a relative minimum probably right there, don't I? So to find the relative minimum, second trace, minimum, 3. To the left, hit enter. Go to the right, hit enter, and hit enter again. Where was it at? -1/3. Okay? Well, you could graph the derivative too, but then it means a different thing. Like if you graph the derivative, where it's positive, it's increasing, where it's negative, it's decreasing. Okay? Okay, where does this one have a relative maximum? Okay, this is a little easier to do than that last one, so I'll actually do it by hand. Where does this have a relative maximum? EV will just do it on your calculator, but I'll go like this, -3x squared plus 6x, okay, equals 0. Factor out a -3x, and we get x minus 2 equals 0. So x equals 0 and x equals 2. So what's in between 0 and 2? 1. So if I stick a 1 into if I stick a 1 into here, I get a negative times a negative, which is a So it's increasing here, it'd be decreasing here, and be decreasing here. If it goes from decreasing to increasing, it's a relative minimum. If it goes from increasing to decreasing, it's a relative maximum. The relative max would be at 2. If I graphed it, this is how I graph it, John. I would say y equals, come on, baby. Y equals, clear. I go negative x raised to the third power, slide over, plus 3x squared minus 4, graph. Okay, it goes down, up, and then down. Okay, the max would be right at 2. I graphed the original function, John, not the first derivative.
I know, but for negative x to the third, and when you're doing that, you gotta put parentheses around it. So
no, you don't. No, you don't put parentheses around it.
Why does it raise though? Why does it raise? This doesn't like raise. It's 3 like it stays up where like if I did plus the 3x, it would still be going.
Oh, dude.
You know what I'm saying? So like that, you know. You can just like what I
Yeah,
put the negative on the outside of that in parentheses. Or put it in parentheses with it.
Let's go mode. Math print. Boom. Second quit. Y equals.
Oh. You're right in the right color, bro. Come on. Oh,
I did. Okay, so then if I graph the first derivative on my calculator, okay. So if I did the first derivative on my calculator, the first derivative would be negative 3x squared plus 6x. If I would graph the first derivative function, okay, the graph of the first derivative function has a, it changes from negative to positive at 0, so then it changes from decreasing to increasing at 0, and then it changes from positive to negative at 2, so it changes from increasing to decreasing at 2, so that's why the max would be at 2. This is the first derivative graph. You have to think differently, because positive is increasing, negative is decreasing. So, because the first derivative is the slope of what the graph is doing.
is it just like a velocity graph?
Yes. Okay, now, here's something different. Relative and absolute are huge in calculus, okay? To find the absolute maximum, we have to check 2 more points, okay? So, we have to check the endpoints plus every critical number in between. So, what's the first derivative of g here? Negative 6x squared plus 6x plus 36, correct? If we take out a negative 6, we get x squared minus x minus 6. If we factor this, how does it factor? X and x, plus and minus, 2 and 3. A positive 2 and a negative 3 add up to negative 1 multiplied by negative 6. Okay? So what are our 2 roots? Negative 2 and a positive 3. So what we have to do on our number line is it starts at negative 3, so I have to check negative 3. I have to check a negative 2. I have to check a 3. And I have to check a 5. Okay? To find the absolute maximum, what I would prefer to do is put each of these numbers into the original equation. Now, what's a quick way of doing this by hand? Well, synthetic division is actually. Oh, don't whine. Negative 2, 3, 36, 0. So if we do this, negative 2, 6, 9, negative 18, 18, negative 54, negative 54. Is that going to be a maximum at negative 54? Probably not. So if I try a negative 2, negative 2, 3, 36, 0. If you're not allowed to use a calculator on this section, this is what you would do. Yeah, there's 2 sections on the AP calculus test that you can't use your calculator. On the CLEP, I'm not sure. I got to read through that more. Okay, negative 2 gives us 4, 7, negative 14. Ooh, what is that? 22, negative 44, negative 44. A little higher. We put in a 3. Negative 2, 3, 36, 0. Negative 2, negative 6, negative 3, negative 9. Positive 27. 81. Well, so far that's a max. Let's try a 5. -2, 3, 36, 0. -2, -10, -7, -35, 1, 5, 0. Where's the absolute max? At 3. Now, if you were Evie-Lers, you would just graph the original equation and find the absolute maximum just by looking at it.
Well, you can't do that.
What? You can do that? Yes, you can. You would check -3. You would trace. Okay, here's how you would do it the Evie-Lers way. Turn on, you piece of. All right, thank you. Hey, I did not say that. I was going to call it a garbage. -2x to the third plus 3x squared plus 36x. If we graph this, okay, I can't see everything, can I? But I don't need to see everything. What I'm going to do is stick. What? Zoom. Whoa. Zoom fit.
Max is 81.
Okay, so what we need to do is trace and see the value at -3. And it's a -27. Because I did zoom fit. So let me go to my window. I don't like that because that's too high. Let's go -60 and let's go 60. So if I go to -3, if I trace to -3, I'm at -27. Okay. If I trace to -2, I'm at -44. If I trace to 3, I'm at 81. If I trace to 5, I'm at 5. So you use your graphing calculator to find the biggest number of those 4 numbers that they give us. Yep. Yeah, you can find the max too, but you have to find where the max curves at. Yeah, the x value of the max. Yeah, you can do it that way. I mean, there's all kinds of different ways to do this. Because sometimes the absolute happens at one of the endpoints. Let's keep going. Let's keep going here. All right. So in this one, the first derivative of h is 6x squared plus 6x minus 12. Take out a 6, and it's x squared plus x minus 2, which is x plus 2, x minus 1, which is -2 and 1, are where the max and mins would, the relative maxes and mins would occur. So, on this one, if we graph it then, 2x squared plus 3x minus 12x plus 5. Looks like that. So, if we try -3, if we trace to -3, -3 gives us 14. If we trace to -2, -2 gives us 25. If we trace to 1, 1 gives us -2. And if we trace to 2, 2 gives us 9. So -2, the minimum would occur at 1. The original function. Yes.
You're looking at on the graph. That's like it's on a line. It's below the minimum, but it's not a curve. It's still minimum.
Yeah, I guess so.
Even if it's like
Yeah, I think I get what you're saying. If you have a point below your relative minimum, that's the minimum. Okay. This one, if we take the first derivative, 4x cubed minus 4x, take out 4x, and third minus 1. So 4x, x plus 1, x minus 1. So it's 0, -1, and 1 are choices. Okay. So what's happening? I'm going to do synthetic again really quick to this. So I'm going to go 1, 0, -2, 0, 0. Because 1x to the fourth, 0x to the third, -2x squared, plus x plus the last number. So if we put in a 0, what's going to happen? 0, 0. Okay. If I put in a negative 1. 1, negative 1, negative 1, 1, negative 1, 1, 1, negative 1, negative 1. So negative 1 gives me a value of negative 1. If I put in a 1, 1, 1, 1, 1, 1, negative 1, negative 1, negative 1, negative 1, negative 1. That is also a negative 1. So what's happening with the graph? Well, it looks like this, and it goes like this, this, this. Okay? Yeah, it does. But it does. It does. You're just too zoomed out to see. Yeah. So it looks like this. If you go zoom 6, just go zoom 6. So what is the absolute max here? There is no maximum value because the maximum value is infinity, and infinity is just a concept, not an actual number. So there is no maximum. Okay. Okay. See ya. Okay. For this one, what's the first derivative of this? Well, we do the quotient rule, which is x squared times 1 over x minus the ln of x times 2x all over x to the fourth, which is x minus ln of 2x ln of x over x to the fourth, which is 1 minus 2 ln of x, which factor out an x and cancel it with one of the x's there. Okay? So if we set this equal to 0, 1 minus 2 ln of x equals 0, how do I solve this? Well, you move the 2 ln of x over to the other side, divide by 2. How do you get ln of x? How do you get the ln out of there? You could e both sides. X equals e to the 1/2 power. Did I do something wrong?
No.
No, it isn't that. So, all right, first derivative, x squared times 1 over x minus the ln of x times 2x over x to the fourth. We factor out an x, 1 minus 2 ln of x over x to the third. Z equals 0, so just the top equals 0. Move, divide, e. So what does the graph of this look like? Okay.
But it's on the x-axis.
Uh-huh.
There's probably none.
How is there still like
Yeah, I factored out this x right here. The x that was in front of it. Yeah, I took out this x. So take out an x out of here. No, that's not. That's different. Because it's hard to explain, but the ln of x is separate from this x. They're two totally separate parts, and so this is like a number. Like, yeah, I'm sorry. Look at, yeah, it's not. Yeah, I'm not gonna be able to explain it. Ooh. Okay, look at this. So y equals clear. The alpha y equals make a fraction. So I get the ln of x over x squared. It'll still be fine. Zoom 6. No. So see, on this, you can see where it kind of goes above the axis there. So if we go second trace and find the maximum 4, we go to the there and go to the right of that little pop over the line there. You can see how it goes higher, and then the numbers will start getting lower here. The y numbers get lower. So there's a maximum there somewhere, and it's at 1.648. So which one of these equals 1.648? I think that one probably.
He's like 2 point something.
2.7, 1828, 1828, 459, 045. So now it wouldn't be that one.
Wait, what do you any of them though?
It's not any of these?
Like those are all gonna be below 1. No.
True. True.
Why did that happen? Change it.
Oh, what is the maximum value? Not where it occurs. Stupid. Birchbach, stupid.
Stupid. Obtuse.
Okay. Okay. So here's what we do. E to the 1/2 was the right answer. I was wondering why that wasn't the right answer. E to the 1/2 is the right answer. You stick it in here. The ln of e to the 1/2 over e to the 1/2 squared. The ln of e to the 1/2 is 1/2 over e to the 1/2 squared is e, which is 1 over 2e, which is c. We're looking for the y value, not the x value.
You can find this by graph.
You can find this by graphic, yes. But, yeah. So I did. What?
Can you just get that question on TV?
No. Okay. It's going to be lunch. I have 5 assignments out for you. We should be good. We're not going on to anything else after lunch.
Doesn't this section have the last